Hello everyone, welcome to my classroom. In today's class, I am going to discuss about decoders and types of decoders. In previous class, we have seen encoders and types of encoders. So decoder, nothing but decoding the input data. So decoders perform exact opposite operation of encoders. Observe, decoder is nothing but a circuit or device that performs conversion operation. So data is converted from one form to another form. In encoder circuit, we know in encoder circuit, octal numbers are converted into binary. So octal numbers are converted into binary. Similarly, decimal numbers are converted into binary. But here in decoders, so binary data is converted into other formats, either octal, either decimal or hexadecimal, whatever it may be. So binary data is converted into other format using decoder circuit. So decoder circuit is having n input lines and 2 power n output lines. N input lines, 2 power n output lines. So I am taking here if n is equal to 2. So 2 input lines and 2 power 2 4 output lines. If n is equal to 3, 3 input lines and 2 power 3 8 output lines. Similarly, if n equal to 4, so 4 input lines and 16 output lines. So I am taking 2 to 4 decoder circuit. Observe, 2 to 4 decoder circuit. If n is equal to 2, so input is having 2 lines and output is having 4 lines. So 2 to 4 decoder circuit. So this is the block diagram of 2 to 4 decoder circuit. Here I am taking two inputs A1, A0. Outputs are D3, D2, D1, D0. And here a special variable I have taken, that is nothing but E. So E is nothing but enable. So if E is equal to 1, then only the circuit is enabled and output is produced. If E is equal to 0, so then the circuit is disabled and outputs are zeros. So observe here, this is the truth table for 2 to 4 decoder. So always check for enable condition. If enable is 0, if enable is 0, so no need to consider the input values, either 0, 0, 0, 1, 1, 0, 1, 1, whatever the input may be. So these two are not at all considered by the decoder circuit. Output is 0. So next, see here, enable is 1, enable is 1, enable is 1, enable is 1, means decoder circuit is enabled and inputs are given to the circuit. So inputs are given to the circuit and output is obtained here. Observe carefully. So first condition, this condition, input is 0, 0, binary to other. So input is binary value 0, 0. 0, 0 means nothing but data 0. So 0, 0 means nothing but 0. So I am placing 1 here and remaining all are zeros. Similarly, 0, 1. 0, 1 means 1. So 1 is here. So I am placing 1 here and remaining are zeros. Similarly, 1, 0. 1, 0 means 2. I am placing 1 here and remaining 3 values are zeros. And 1, 1. 1, 1 means 3. So here it is 3. So 3, I am placing 1 here and remaining values are zeros. This is truth table for 2 to 4 decoder. Remember, always enable must be 1, then only output is generated. If enable is 0, so output is 0. Next, we need to draw or we need to derive Boolean expressions for D3, D2, D1 and D0. So observe D3. So D3 is 1 for E1, A1, A0, 0. So D3 is 1 for this case. Nothing but E1 means E, A1 1 means A1, A0 1 means A0. So I have written here D3 E, A1, A0. Next, D2. D2 is 1 here. For E, E1 means E. A1, 1. Again, A0, 0. So, E, A1, A0 bar. E, A1, A0 bar. This is D2. Next, sorry, D1. This is D1. Observe here. D1 is 1. So, here D1 is 1 for E1, A1, 0, A0, 1. Means E, A1 bar, A0. E, A1 bar, A0. Similarly, D0. So, I have written D3, D2, D1, D0 Boolean expressions here. So, based on these Boolean expressions, so this is the logic circuit I have drawn. Observe, enable I have taken, and enable is given to all these 4 AND gates, because so dot means AND gate. Enable is given to all these AND gates. So because E is present in all these cases. Next, A1, A0 I have taken. So A1, A0 and E. A1, A0 and E. So D3. So this is D3. Similarly, D2, D1, D0. So this is the logic circuit for 2 to 4 decoder circuit. Next we will see 3 to 8 decoder. Observe, 3 to 8 decoder. 3 to 8 decoder is having 3 input lines and 2 power 3, 8 output lines. See, A, B, C are my 3 input lines and enable and 8 output lines D0 to D7. This is the block diagram for 3 to 8 decoder circuit. Next, this is the truth table. So, enable A, B, C 3 inputs and 8 outputs I have taken. Observe here, enable, inputs and outputs. So, as we have discussed, enable must be 1, then only outputs are obtained. Here enable is 0. So, enable is 0. So, no need to consider the input values. No need to consider the input values. Output is 0 for enable 0. Enable 1, then only the decoder is enabled and input is going to be considered. Enable is 1 and input is 0, 0, 0 means 0. So check for 0. Here I have 0. So place 1 here and remaining all are zeros. Consider this one. Enable is 1. Okay. 1, 0, 0. 1, 0, 0 means 4. Check for 4. Here I have 4. So I am placing 1 here and remaining all outputs are zeros. So go for this one. Enable is 1. Okay. 1, 1, 1. 1, 1, 1 means 7. So here I have 7. So place 1 here and remaining all are zeros. So this is the way to fill the truth table. Next, implementing Boolean expressions for these output values. First, I am taking D1. Observe D1. Here. So D1. So D1 is 1 here. So D1 is 1 for this condition. So enable 1, A0, B0, C. See here. So I have not considered enable value. I have taken ABC only. Observe. A is 0 means A bar. B is 0 means B bar. C is 1 means C. So A bar, B bar, C. That is the Boolean expression for D1. See, D1. Similarly, check for D5. So D5, these are the inputs. 1, 0, 1. So A is 1. B is 0 means B bar. C is 1. A, B bar, C. D5, A, B bar, C. Similarly, D7. So D7 is A1, B1, C1 means A, B, C. D7, A, B, C. So these are the Boolean expressions. You have to write Boolean expressions all for D7 to D0. I have written all the Boolean expressions here. So based on the Boolean expressions, I am going to draw the logic circuit. So this is the logic circuit. A, B, C are my inputs and these are my outputs. So D0 to D7 my outputs. So this is the logic circuit. Try this circuit on your own. So see here, implementing with 2 to 4 decoders. This is the same topic. So nothing but the 3 to 8 decoder topic. So I am implementing the 3 to 8 decoder using 2 to 4 decoders because so implementing this is okay, but implementing 4 to 16 decoder becomes very complex. So implementing one decoder using another decoder I am taking here. So let us implement 3 to 8 decoder using 2 to 4 decoders. So we know 2 to 4 decoder is having 2 inputs, 4 outputs. We know 3 to 8 decoder is having 3 inputs, 8 outputs. These two are known to us. Next, this is the formula. So observe required number of lower order decoders. Here, this is higher order, this is lower order. So to design this circuit, required number of lower order decoders, this is the formula M2 by M1, where M1 is number of outputs of lower order. Observe, M1 is number of outputs of lower order. Lower order is 2 to 4. 4 outputs, M1 is 4. Next, M2 is number of outputs of higher order. Higher order means 3 to 8. For 3 to 8, 8 outputs. So I have taken 8. M2 by M1. So 8 by 4, 2. Observe carefully. M2 by M1 is the formula. So the required number of 2 to 4 decoders to design 3 to 8 is 2. We require 2 to 4 decoders. 2 to 4 decoders to design one 3 to 8 decoder. Observe here. So this is 3 to 8 decoder. I have taken 2 2 to 4 decoders here. This is first decoder. This is second decoder. Based on these two, so based on these two, I need to derive 3 to 8 decoder circuit. This is the block diagram for 3 to 8 decoder using 2 to 4 decoders. So we know 2 to 4 decoders having only 2 inputs. So observe 2 inputs and this is nothing but, so observe A2 is nothing but, so extra variable, that is nothing but enable value. So here consider this is 1. So 1 is directly given here. But here I have taken not get. So I am taking 1 and here it is 0. So A2 is 1 and 1 is directly given to this first decoder circuit and A2 is 0 for this second decoder circuit. So because of this NOT gate, and these are my outputs. This is block diagram of 2 to 4 decoder circuits. Next, this is the truth table. So truth table is having A2, A1, A0, A2, A1, A0 and outputs D7 to D0, D7 to D0. So first condition is, so X, 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 don't care condition, always don't care condition. So don't care conditions results output 0. No need to think about this term. Next, 0, 0, 0. Observe here. So here we have to place some important role. So A1, A0, two inputs. So they may be either 0, 0 or 0, 1 or 1, 0 or 1 1. First I am giving 0 0. So here 0 0, here 0 0. Now come here. A2 is 1. So 1. I am placing 1 here. So I am placing 0 here because here it is not yet. So 1 0 0 0 0 0 because this is total input is here 0. Here input is 1 0 0 means 4. So it results 4. It results 0. So first output is obtained. Next I am giving 0 1. So this is 1 and this is 1. 1 1 0 means 6. 0 1 0 means 2. Observe carefully. So this is the way we have to draw the truth table. So 4 conditions are zeros, 4 conditions are ones. So for 4 conditions A2 is 0. For 4 conditions A2 is 1 and input is 0 0 0 1 1 0 1 1. So these are same but A2 is differed here. So based on this 0 0 0 means we know 0. I have placed 1 here. Next 0 0 1 means 1. So 1. Again 1 0 0 means 4. So this is the 4. I have placing 1 here and remaining are zeros. Next 1 1 0 means 6. So here I am having 6. So 6 I am placing 1 and remaining all zeros. 1 1 1 means 7. So place 1 here and remaining are zeros. So this is the way to fill truth table for 328 decoder using two 224 decoders. So for this I have written Boolean expressions. Boolean expressions for these output values I have written. Next, this is the logic circuit diagram for 328 decoder using two 224 decoders. So again try this circuit based on these Boolean expressions. So this is second way of implementing 328 decoder. First way is direct implementation. Second way is by using 224 decoders. Next, we'll see 4 to 16 decoder circuit. Okay, 4 to 16. If n is equal to 4, so n equal to 4 means 4 input lines and 2 power 4 16 output lines we know. So 4 to 16 decoder. So observe here, I am taking 4 to 16 decoder circuit using 3 to 8 decoders. So 3 to 8 decoders. By considering lower order decoder, I am designing higher order decoder. We know the formula. So that is nothing but M2 by M1. M2 is higher order output number. So higher order means 4 to 16. 16 is the M2 value. M1 is lower order. Lower order M1 is nothing but 8. So 16 by 8 means 2. We require 2 3 to 8 decoder circuits to design one 4 to 16. So to design a 4 to 16 decoder circuit, we require two number of 3 to 8 decoder circuits. So this is the formula. Next, so observe, this is the block diagram. Here I have taken, this is my first 3 to 8 decoder. This is my second decoder circuit. We know 3 to 8 decoder is having 3 inputs. So I have taken 3 inputs. So either 0, 0, 0 or last one 1 1. We know 3 zeros to 3 ones, total 8 values. Okay, so 3 inputs initially I have considered. So I am placing 0 0 0 here and again here 0 0 0. Observe A3 is input for enable. Consider always A3 1. So 1 is as it is given here and it is not yet, so it is 0. 0 0 0 0, all zeros means nothing but 0 is my output. So observe here 1 0 0 0, 1 0 0 0, nothing but D8 is my output. Observe first A3, A2, A1, A0. So A3, A2. So this is my A2, A1, A0, 1 0 0 0. So 8 is output. Next consider, so 0 0 1. So 0 0 1 and this is 1. So 0 0 1. So observe here 0 is going here, 0 is going here and 1 is going here. So this is 1. Again this is 1. So A3, next A2, A1, A0, 1 1 0 0, 1 1 0 0 is nothing but 12. So 12 is my output here. Next observe here A3 means 0. Next A2 1. So 0 1. A1 is 0. A0 is 0. 0 1 0 0 means nothing but 4. This is my output. Similarly, we have to do for all these. So this is only to verify this circuit. So based on this, I am going to draw my truth table. Observe truth table. This is the truth table. A3, A2, A1, A0. If we see this carefully, for 8 cases, A3 is directly 1. For 8 cases, A3 is directly 0 because we know. So 0, 0, 0 to 1, 1, 1. Total 8 cases. For 8 cases, A3 is 1. For 8 cases, A3 is 0. So see here. For 8 cases, I have taken A3 value 0. For remaining 8 cases, A3 is 1. And 0, 0, 0, 1. Observe here. First one and second one. Again 0 0 1 0 0 1. So 0 to 7, 0 to 7. All these are common, but these values are going to change because of this NOT gate. So observe, for 8 cases A3 is 0, for the remaining 8 cases A3 is 1. So first one, if this is the input, if this is the input, so 0 0 0 0 means D0. So here I am placing 1 and remaining all are zeros. Consider next one more condition here. So this one 0 1 0 1 means 5. Check here D5. I have to place 1 here and remaining all are zeros. Next one more 1 0 1 1. Observe 1 0 1 1. It is nothing but 11. So check where is 11. Here I have. So I am placing 1 here and remaining are zeros. Similarly, one more 1 1 1 0. 1 1 1 0 means nothing but 14. So here I have 14. I am placing 1 here and remaining are zeros because this is my input and 14 is my output. So this is the way to fill truth table. So next you have to write Boolean expression for D0, D1, D2 and so on up to D15. Write it on your own. And this is the logic circuit. So again implement this circuit using the Boolean expressions what you have derived. So again try to draw this on your own. Next, okay, in next class I am going to deal with multiplexers and demultiplexers. So far we have discussed decoders and types of decoders. Thank you.